Okay, in section 4.3, we're going to talk about composition of functions with reference triangles. And the purpose in this is because sometimes we will have inverses that are not common values from the unit circle. So when we have something like this, we need to again go back to our reference triangle so that we can solve. So here are a series of strategies. The first thing we want to do is make an equation with the inner function and set it equal to theta. Okay, so that will be our theta. And then what we'll do is draw a reference triangle in the appropriate quadrant based on the restrictions from the inverse function. So let's review those. For the inverse sign, we have to remember that our values will lie in quadrants 1, where our values are positive, and 4, where our values are negative. For inverse cosine, we need to remember that the values will lie in quadrants 1 for positive and 2 for negative. For inverse tangent, again, we're in first for positive and fourth for negative, but remember the quadrantals of negative pi over 2 and pi over 2 do not count because those are asymptotes. And then for inverse cotangent, we're in 1 for positive and 2 again for negative. And again, vertical asymptotes, which are the quadrantals at the beginning and end, do not count. So then what we want to do is find the missing side using the Pythagorean Theorem. Okay, again, as I stated many, many times, this does not go away. Then we'll state the ratio of the outer function using the reference triangle. Okay, so these are a series of steps. I'm going to show you how we'll use them. So let's take a look at problem number 2. Okay, so the first thing we want to do is take this inside, okay, and we're going to set it equal to theta. So this is going to be our theta right here. So we're going to say we want the inverse sine of negative square root of 2 over 3 to be equal to theta. Now this looks like it could be a value from the unit circle, but it's not. So then we're going to multiply both sides by sine, giving us the sine of theta is equal to negative square root of 2 over 3. When we have a negative value, this means that our reference triangle will be in the fourth quadrant. Okay, and this goes back up to the top. Inverse sine, negative is in fourth. So I'm going to draw my reference triangle here. This is y over r. So we're going to use the Pythagorean theorem to get our x value. So that means we have x squared plus y squared is equal to r squared. So this is x squared plus 4 is equal to 9. Subtract. Would help if I could say this is 2. Square root of 2 squared is not 4, it's 2. Subtract. X squared is equal to 7. And because our x value here is positive, x is equal to the square root of 7. So watch that error. Okay, so now we know if the sine of theta is negative square root of 3 over 2, if this is my theta, which we used, I'm going to replace this with theta, and what we're looking for is the cosine of theta. This represents theta. So cosine is going to be my x over my r. So this final answer is the square root of 7 over 3.